An interesting application of the ideal gas law is swimming and diving. When you dive beneath the surface of water, your body experiences an increase in pressure. That's because the water has mass, and that mass pushing down on your body increases pressure. The increase in pressure goes for every 10 meters in depth, you get an additional 1 atmosphere of pressure. So if you're at depth and you hold your breath with a fixed amount of air in your lungs and you ascend, that can actually be dangerous as that volume expands. Which is the most dangerous is the question I have for you. If you ascend from 10 meters to the surface, from 20 meters to 10 meters, or from 50 meters to 30 meters below the surface, which of those creates the greatest danger if your breath is held? Think about that for a minute and make a selection. Let's look at possible explanations for each of the answers. A, between the surface and 10 meters, the pressure doubles. That's the greatest change in pressure, and therefore the greatest danger. B, between 20 meters and 10 meters, the depth doubles. So that's the greatest change in depth. Or C, it's the deepest ascent. You start at 50 meters down, so it's the most dangerous pressure change. Think about those 3 possible options and make a selection. We're talking about diving, and when you dive beneath the surface of water, the pressure changes. 1 atmosphere for every 10 meters in change of depth. So how can I calculate the volume in my lungs, how that will change? If I hold my breath and fix the amount of air, then the volume will expand or contract with the pressure changes. As I ascend, the volume wants to increase because the pressure decreases. And if I hold my breath, that increase in volume can actually damage my lung tissues and my chest cavity. So let's look at this. If we have a change in pressure and volume at constant temperature, the product of the pressure and volume, P times V, is a constant. So P2 times V2 is P1 times V1, and I can solve for the second volume, knowing the first volume and the change in pressure. It looks like this. Let's do that for each ascent. So from 50 meters to 30 meters, the deepest, we go V2 is 6/4 V1. That's a change of 6 atmospheres to 4 atmospheres. If I go from 20 meters to 10 meters, 3 to 2 atmospheres. And from 10 meters to the surface, 2 to 1 atmosphere. So this is a change of 2, a factor of 2 in volume. The volume will double if I do this ascent. These two are a factor of 1.5. So it's interesting that the greatest change in volume occurs nearest the surface. And since that's where we do most of our swimming, that's where we have to be most careful. So the greatest danger in holding your breath, you get the greatest volume change due to pressure, is from 10 meters to the surface.